All right, off to this second session for the day. So Gabriele Montanari from Eurotech. Gabriele, he's the IoT Global Product Manager and Solution Architect at Eurotech. Gabriele, at a young age, he carries out his scientific studies in Udine, North Italy. By the way, it's a beautiful city. And chooses to interrupt his university career to found his first startup at the age of 22, of which he became the CEO, and which he works for the next 6 years developing IT solutions and products for companies all over the world. After that, he chooses to start his career in Eurotech in the year of 2019. He works also on improving his IoT knowledge and skills as a field application engineer and then a solution architect after, following important customers of the company and the development of IoT architectures. At this point, he chooses to combine the skills developed also in the previous work experience to accept the role of Eurotech's Global IoT Software Product Manager. Welcome on board, Gabriele. We're excited for your talk today, and off to you.
Thank you. Hello, everybody. Thanks for joining. First of all, I'm glad to introduce myself. I'm Gabriele Montanari, and at the moment, I'm the Eurotech software product owner. Last year at the Eclipse IoT Edge days, we have seen together the relevant aspects of compromise integration, talking about interoperability, easy third-party integration, connection, both at the edge and into the cloud. And starting from the inputs collected in the recent months, I wondered what could be one of the other main relevant aspects to be explored when we are talking about IoT architectures and edge computing. And the answer was relatively simple, because it's security, as you know. So the purpose of today's speech is giving you a quick overview of how the open source software can be considered the basis of rugged and certified deployment for a secure high-value scale at the edge, with a direct reference to the Eurotech recent successful stories in terms of strong hardening, best-in-class security standards, and certifications. Hope you will appreciate this kind of inputs. I've decided to articulate my presentation starting from a very briefly overview of what the market currently suggests, so as to define what are the main challenges every software developer have to face off nowadays. First of all, we'll go through a quick introduction of the main trends in the 2022 edge computing worldwide market. On that, the world pandemic is certainly one of the factors that affected the substantial increase of performances at the edge, and later in the presentation, we will see deepen some of these relevant aspects. Security, as you know, is one of the most important challenges, and it turns out to be an essential factor for any company to evaluate the introduction of software solution. On that, we'll analyze the differentiation between ICT security and cyber security, so as to make a drill down on best practices we must put in place to face off security vulnerabilities challenges. The section 3 regards Eclipse open source software. Here we are referring to the added value of an integrated edge to cloud software solution, including Cura, the powerful edge framework, and Capua, the edge management platform. We'll do a quick overview of the technical and operational perimeter of the Eclipse software stack, so as to understand which part of data and management pipeline we are referring to when we talk about rugged security that allows customers to face the risk of potential hack. This is the first inputs for introducing IEC 62443, the open source software, as a real starting point of the best cybersecurity standards. On that, we'll introduce key concepts structure and requirements of the certification and clarify purpose and rationale of fundamental requirements, so as to be able to complete the presentation with our recent case history, that essentially is the Everywhere IoT 62443 certification. So let's start with the 2022 Edge and Cloud Computing markets main trends. During this year's coronavirus outbreaks and the use of cloud computing technologies has essentially exploded. Across the world, millions of users started to use cloud-based platforms to collaborate, shop online, or entertain themselves. Cloud computing technologies for healthcare have gained attention even from corporate users worried about things like privacy, compliance, etc. And as you can see, I've tried to summarize the main trends, identifying 6 main points. First, cloud strategy and transformation. Here, the top trend in this field is the evolution of hybrid and multi-cloud, connecting public clouds to other public clouds and on-site workloads. The second is cognitive and intelligence cloud. Artificial intelligence as a service is bringing services like marketing intelligence, customer service, robotic process automation, and analytics to a wider audience. The third regards the high-performance computing and big data cloud as use cases in need of fast and high processing power that are constantly increasing, and that cloud providers are adding high-performance computing to their services, and quantum cloud is gaining also popularity. Then we are referring to cloud native technology stack. Top trends in this area are cloud automation and orchestration, cloud containers, and serverless computing structure. Edge computing and distributed cloud for sure, and specific on that we will go deeper in the next slides. And obviously, for closing this little summary, we are referring to application and industry-specific solution that focus on the actual needs of verticals that intersect essentially all the IoT markets. So there are essentially 4 many fundamental reasons why edge computing can play a vital role in IT/OT architectures. The first regard latency, real-time or at least near real-time requirements. This concern in particular the work path of data acquisition and transmissions, both in an aggregate and in a raw form, directly from the field, and with the aim of having it available in real time in order to trigger various kinds of processes. Connectivity regards essentially computing powers in areas where broadband connectivity or mobile is not available. We're referring to typical distributed IoT architectures underground in the mountains or in the middle of the sea. The third point regards security and privacy, that essentially is everything regarding data availability, perimeter, the availability of the perimeter definition of data. This is obviously related in particular to those low aspects that essentially evolve in parallel with technologies, let me say, with a bit of delay. And finally, connection cost and transmitted data volumes. The scope here is rugged data processing at the edge and gathering only the results into the cloud. Obviously, as for any kind of solution a customer wants to introduce, the relevant aspect is certainly that the total cost ownership must intersect rights the technological and operational aspects. But let me share you with a couple of notes regarding security. As anticipated, the strong expansion of edge computing technology accelerated also by the pandemic emergency, is leading to a literally new digital war, in which the issues of IT/OT security take on an even more relevant role. According to the most important worldwide analyst researches, over next 5 years, there will be a 70% increase on the total data processed by companies that are using smart edge models. A trend that will strengthen the decentralization adoption of computer resources related cloud computing, digital workspaces, networks and data storage, etc. But however, the same extension of the perimeter of IT/OT architecture requires a further high level of security and protection. But here the question essentially is what impact is having such an expansion of the cybersecurity approach? The configuration of a constantly growing edge, which includes cloud providers, smart city, augmented reality, and the wide use of AI, is testing both service provider and telecommunication companies. At the same time, it is a huge possibility of expansion of the business through new applications. The evolution of edge computing also involves important infrastructure changes, problems and solutions for the management of a huge flow of data, which with the recent use of telework and agile work has exponentially increased diffusion of cybersecurity. But also particular attention to the data protection methods are the core of this kind of intervention. And the transparency of data storage and backup services also have a vital role in regarding this specific topic. So first of all, we try to clarify the difference between ICT security and cybersecurity. When we talk about ICT security, the reference is to the point of intersection between the physical and the logical world. It therefore stands a link between information security and cybersecurity, which operates exclusively in the cybernetic dimension. Therefore, information security concerns the protection of information in all environments, while cybersecurity treats the protection of what arrives in the cyberspace through the ICT infrastructure. So cybersecurity is all about security of anything in a cyber realm, and information security is all about security of information regardless of the realm. ICT security includes both services that are connected to the internet and thus connected to other types of network. So all those communicating devices, those also dealing with the supply chain security, SCADA system, etc. The difference between the three types of security, however, is not clear as the areas on which they apply and the technologies are used. Moreover, all three are required to guarantee availability, confidentiality, and integrity of the assets. By depending the aspects that distinguish the information and communication technology security, we must consider that they are the set of methodologies, processes, practices, and technological tools that are used to receive, transfer, and process data and information. The key elements for an effective ICT security system are: first, secure the monitoring and controlled access to reserved information, the safe transmission of data, and safe data storage and elimination. In order to reduce security risks and minimize the impact of possible safety accidents, it is essential to prepare a change management and risk assessment plan to guarantee business continuity following the logic of risk management. ICT security must also develop event and crisis management procedures by preparing a disaster recovery model capable of restoring the service and safeguarding the business in case of a cyber attack. So ICT security must guarantee resilience even in extreme scenarios, such as a data breach or a ransomware attack, or different kind of issues could happen. With the increase of cyber attacks, computer resilience is becoming more important than ever. Every size of companies, from world organization up to individuals, are increasingly taking threats of greater gravity and with significant costs. Thus, the agendas and work tables on this subject become increasingly participated, and this is because the cyber resilience requires a strategy capable of resisting IT attacks in order to preserve its organization from significant unpleasant consequences, like, for example, loss of trust and reputation, both individually and for the brand or the company, or high financial cost for investigation or data recovery activities. For this reason, it becomes increasingly necessary to put in place a security strategy capable of minimizing the risks that the attacks reach the heart of the systems, the application data, and this is carried out through an effective phase of early detection that substantially is creating an efficient identification and analysis capable of triggering fast responses before the damage can spread the entire system. Note that preparing to respond, recovering from a computer attack is not something trivial, but it must be carefully designed, planned, and tested so as to intervene in the shortest and most efficient possible time. Note that a complete strategy of IT resilience should always include any fundamental elements like identification. This function focuses on the need to understand its assets and important resources. Effective protection and detection. This function focuses on the measures that warn an organization of IT attacks, which could include anomalies and events. So is everything regarding the continuous monitoring of the safety and timeliness of the detection processes. Answer to the accidents. Sure, this function guarantees an adequate response to IT attacks and other IT security events, including response planning, communication, analysis, mitigation, and improvements. And recovery procedures that ensuring operational and business continuity, but there is a fundamental difference between the design and the implementation of a traditional, let me say, a traditional resilience solution compared to a computer resilience solution. Traditional resilience must protect from situations in which the data are in the normal state, but it may be necessary to synchronize or restore them to a pre-system stage. Computer resilience, on the other hand, must protect and respond to situations in which systems and data are intentionally damaged or differently delete or encrypt. This entails the adoption of a plan capable of protecting data and systems in their continuous evolution by minimizing any damage and interruptions that essentially could derive from possible threats. Note that only resilience strategy is not enough because the biggest challenge launched by a computer hack is to note that the system has been compromised or that an hacker has achieved successful access somewhere in the company's environment by intervening even before the damage can be verified. In other terms, on that, awareness is everything. Many studies show several cases in which an attacker may have worked without having been detected for several months before starting the actual hack, in search of the weak points or to obtain higher privileges and the spread of the malware to conduct the attack. So the real full computer resilience begins starting from the detection of intrusions, the monitoring of unusual behaviors by individuals, by the monitoring of programs and systems, from reports, alarms, and dashboards useful to notify the safety team suspicious behavior. In other terms, all the investments in technologies, tools, processes, and monitoring, but also education and communication, would have served nothing if they do not allow to intervene even before an accident occurred. But now let's define the technological perimeter of the Eclipse Edge software solution we are referring to. First of all, today the market essentially articulates its demand around three main needs, starting from the left part. First, acquiring data from the field. Second, process each of these data in real time in the simplest, fastest, and most effective way. Third, ensure an easy third-party connection with different kind of infrastructure, different kind of application, cloud instances, where storing data, process them, and possibly make them available through a web dashboard or other different tools. All these referring to the data pipeline, to which the device management platform is approached, so to have a complete functional, easy manageable, and scalable infrastructure. The Eclipse software stack makes essentially all this available. It guarantees an efficient data acquisition with the most important three protocols in order to interface the Edge framework to any type of field device. It also guarantees simple and intuitive data processing through an efficient web UI that proposes some amazing features, like, for example, wires. That is a no-code programming solution integrated with the Eclipse marketplace, and an excellent solution for the integration of bundles and packages for creating your own Edge application in a few minutes, essentially, so quickly and intuitively. Also for actors that hadn't specifically programming skills. All of that is managed through the Edge and Gateway Devices Management Platform, the platform with which it's possible to control and manage all field devices, including gateways, and which allows to instant interfacing with customer web dashboards, with open source dashboards and web analytics platform, such as, for example, a Grafana dashboard and also other third-party cloud platform if needed. Microsoft Azure and Amazon IoT certified cloud connection, in fact, allow also a quick and secure connection to the cloud and the third-party services, so as to guarantee the secure connection and publication of data in most of the main cloud platform currently available in worldwide market. As I told, all these features are then perfectly integrated with the device management platform, which also allows to the full control of the entire management pipeline, also guarantee an easy third-party integration using REST APIs. In the proposed architecture model, each of the building blocks can have one or more different connotations. Specifically on that, when we talk about the Edge framework, as you know, we are referring to Cura, and in the case of the Edge and device management platform, we are referring to Kapua. And each of the two software components is based on a Java SGI technology, which aims to make an intuitive and easy to use interface available to different personas we work on the IoT architecture. In particular, here the added value, as I told, is that everyone can intersect the complexity of the activities of the two platforms on the basis of the effective technical and not skills. A developer, for example, will be able to create his own Java modules from scratch and deploy them as packages directly from the Eclipse development environment. A product manager differently, or an analyst will be able to take advantage using the amazing no-code and drag and drop features to be able to easily compose his own application flow. So starting from the main needs of an IoT architecture, the first goal is to be able to effectively acquire and process the field data and create an interface with different types of field device, and for sure their own protocols. Cura also, yes, introduce a model based on the concepts of drivers and assets to simplify the communication with the field device that essentially are attached to the gateway. Essentially, you can think about the drivers and assets in different kind of differentiation like this. A driver encapsulates the communication protocol and the configuration parameters. It opens, closes, and performs the communication with the end field device. And it also exposes field protocol specific information that can be used by upper levels of abstraction to simplify essentially the interaction with the end devices. An asset differently is a logical representation of a field device described essentially by a list of channels. The asset uses a specific driver instance to communicate with the underlying device, and it models a generic device resource as a channel. And in this way, each asset has multiple channels for reading and writing data from or to an industrial device. All of that is managed through the very intuitive Cura web UI with which the Kapua call is integrated to through the certified cloud connection. Kapua, in fact, is a modular platform provide the services required to manage IoT gateways and smart edge devices. It provides a core integration framework and an initial set of core IoT services, including a device registry, for example, device management services, etc. The Cura Gateway console exposes all services necessary for connecting to Kapua through the MQTT data transport. The service that provides the ability to connect to a remote broker, essentially, and publish messages, subscribes topics, receive messages on the subscribed topics, or disconnect from the remote message broker. Also, Kapua exposes REST API, which can be used to access data and invoked Kapua operation. REST API application finally is running as a dedicated Java process and allows you to integrate your IoT hub also with existing third-party web platform in a very, very easy and intuitive way. So essentially, everything we have seen allows you to create a digital twin of a physical device, the digital twin that allows to abstract the business model of any company that wants to insert this kind of IoT solution. And in this way, the owner will be able to manage this kind of digital twin, control it and simulate its development also in a predictive way by integrating, for example, an AI tool as a service directly into the Edge framework. So Edge computing essentially enables systems to perform data processing at the edge of the network near the source of data. This reduces the communication bandwidth needed between sensors and the central data center by performing analytics and knowledge generation at or near the source of data. ESF is the enterprise version of Cura framework. That is the open source based Java SGI IoT Edge framework for IoT gateways, and through the intuitive web UI enables developers to develop and manage IoT Edge computing application easy connect to IoT devices and cloud services using IoT industrial protocols, and visually compose data flows to manage, analyze, and route data. Thanks to its Java OS GI basis, ESF and its application can be ported across different system hardware architectures and can be dynamically updated. Last but not least, it prevents vendor lock-ins and guarantees the protection of the software investments. At the same time, Everywhere Cloud is, as you know, the enterprise version of open source Kapua, and it addresses the integration needs of an IoT applications. The platform provides all the services required for the management of IoT gateways and devices directly into the field, including the part of configuration management, application lifecycle, and remote access. It also provides the services needed to collect data from the field and integrate into downstream application, business processes, dashboards, or reports, for example. Being EC, the integration hub between IoT devices and the IT infrastructure, we can refer also to it as an IoT integration platform. And the combination between the enterprise version of the Eclipse open source software components are essentially the basis of rugged and certified deployment for a secure high-value scale at the edge. And now we will discover specifically how. ESF specifically ensures the strict Java and OSGI security policies that are enforced at runtime, and verifies that only software signed by the approved authorities is installed and enabled. Moreover, in order to IEC 62443 security compliance, ESF maintains a list of security guidelines to be followed when hardening an IoT device, like the unique device identity and credentials, for example, signed ESF application code, encrypted configuration and storage, and TPM 2.0 identifier and storage support, the full compliance of system integrity and trusted execution, and the full secure management, the audit and OTA updates for all the software components on the device. But more in detail, what is IEC 62443? The 62443 certification was developed to secure industrial automation and control systems throughout their life cycle. It currently includes 9 different standards, technical reports, and technical specifications. 62443 was initially developed for the industrial process sector, but industrial automation and control system are found in an ever-expanding range of domains and industries, such as power and energy supply and distribution, or transport. Such on that, IT standards are not appropriate for industrial automation and control system and other operation technological environments. For example, they have different performance and availability requirements and equipment lifetime. Moreover, cyber attacks and IT system have essentially economic consequences, while differently cyber attacks on critical infrastructure can also be dramatic or even threaten public health and lives. So international standards are essentially based on industry best practices and reached by consensus. Implementing 62443 can mitigate the effects and often prevent successful cyber attacks. It can boost the security throughout the life cycle and for sure reduce also the cost. IEC 62443, this is not only the technology that comprises a control system, but also the work processes and control measures and employees. The standard takes a holistic approach because not all risks are technologically based, because the staff responsible for an industrial automation and control system must have the required training, knowledge, and skills to ensure security. The certification takes a risk-based approach to cybersecurity, which is based on the concept that it is neither efficient or nor sustainable to try to protect all assets in equal measure. Instead, users must identify what is most valuable and requirements the greatest protection and identify essentially the vulnerabilities. The IEC 62443 standard provides the measures that has to be implemented to improve the security of industrial automation control system. The aim of the standard is that the product supplier, integrator, or an asset owner follow a secure practice in a secure environment with secure system and components, essentially. And this in each vertical we can consider for this kind of certification. The IEC 62443 also you can consider it as a guideline for the buyer of industrial automation and control system equipment or equipment or solution. How to choose the right candidate and what to consider also in third-party contracts from a security perspective and to protect the planned investment. So many enterprises are using Industry 4.0 technologies, but only few are able to prove their compliance level according to 62443 for the time being. When a certification is not time and forth, 62443 can be used as a guidance for OT according to the best practices about the main security topics actually the market is proposing. So just a quick resume of the structure of the certification. The 62443 series of standard is organized into 4 different parts. The first is the general one that covers topics that are common to entire series, for example, terminology, concepts, and models, policies, and procedures. The part 2 focuses on methods and the processes associated with industrial automation and control system security. Part 3 is about requirements at the system levels, and part 4 provides detailed requirements for industrial automation and control system production. In addition, IEC conformity assessment verifies that standards are properly applied in real-world technical systems. Here we have briefly summarized also what are the product development requirements requested by 62443, referring to security management and different kind of specification on that direction, also including security requirements, security by designs. That means that a certified solution is designed with cybersecurity best practices embedded in its DNA. Operators can really on a safe and protected environment throughout the whole product life cycle. Then the focus will be both in implementation, update, verification, and testing. And management of security-related issues is the process used for handling security-related issues of a product that has been configured to employ its defense in a dedicated security context, and on top of guidelines are related also into the documentation has to be provided to integrate, configure, and maintain the defense in depth strategy of the product. The other side of the moon is related to purpose and rationale of the foundational requirements divided in categories and related rational summary. So we are referring to authentication, use control, system integrity, the part of data confidentiality, restrict data flow, timely response to event and resource availability, and essentially here everything regarding the complete process mapping of an edge software use. Okay, so considering everything we have seen, when we are referring to the best-in-class cybersecurity standards for industrial automation and control systems, we are referring to IEC 62443. This is substantially a series of international recognized standards that specify the process and the product requirements for the secure development and deployment. It therefore addresses Industry 4.0 operations, system integrators and product manufacturers, and their compliance to cybersecurity best practices. 6244341 certification specifies process requirements for the secure development of products. This certification ensures the highest level of cybersecurity throughout the whole product and application life cycle. The completion of the certification process confirms that the integrated solution follows a cybersecurity by design approach, embedded security best practices in its DNA, and ensuring safety at every stage of the product lifecycle management, including vulnerability response assessments. The IEC 6244342 standard is also particularly important because it addresses the security of the components, in this case both hardware and software, that have to be integrated into industrial automation and control system. An important concept highlighted in this standard is the one of hardening, which implies that device and software must integrate specific security features to ensure a further level of protection against cyber attacks. Just a note related to infrastructure, the gateway we are referring to is the Eurotech Relia Gate 1014, that is an industrial IoT Edge gateway with sophisticated security features and already a PSA certified level 1. To be fully compliant with the 62443 standard. It has been provided with specific device hardening features to furtherly enhance the security. Integrated with Eurotech's IoT Edge framework, this 1014, that is also PSA certified level 1 and integrating advanced security features such as device integrity management, encrypted configuration, and storage, and for sure the part of secure over-the-air updates for all the software components on the device. It essentially enables industrial-grade solution compliant with IEC 6244342 standard. So, resuming, starting from the adoption of the Eclipse open source based software building blocks, we are able to develop and deploy cybersecure by design application on top of the Enterprise Edge framework, adopting all the best practices requested for a rugged and certified deployment and secure high-value scale. Directly at the edge. The full end-to-end cybersecurity compliance is related to sophisticated cybersecurity features from the edge to the cloud, from the embedded device to the edge software to communication protocols and cloud IoT integration platform. This is amazing because it emphasizes the concept that we can provide a best-in-class high-demanding security standard edge solution, also considering all the benefits of an open source based technology, like for example, agnosticity and the full commitment of the open standards. Okay. I think that the time is over. So that's all for today's presentation. I don't know if there are any doubts or questions. If yes, feel free also to contact me at the end of the speech. Here are my direct contacts. Thank you.
Sounds great. Thank you so much, Gabriele. So I'm looking at the questions. No questions so far, but one follow-up comment. Just following up your presentation title. Indeed, there is no compromise when it comes to security at the edge. And speaking about that, it's worth mentioning that the Edge Native working group. Has started beginning of April a new thought leadership initiative, which is a publication on medium.org. So that publication was mainly led by Robert Andres from Eurotech and Kilton Hopkins from EdgeWorks, as well as my colleague Frederic Debian from the Eclipse Foundation. So ideally, this publication, we started with a series of four publications, out of which three has already been published so far, and the final one is coming in a week time. That talks about security at the edge and the importance of security at the edge. So I'll make sure to put the link in the chat box. If you haven't got the chance yet to look at the publications, please do so. Lots of interesting thought leadership publications are going to be out in the next coming weeks, which is IoT and Edge related. Thank you once more, Gabriele.